Hello, welcome once again to another wonderful video by the Simplifier One. I appreciate those of you that have sent comments and your likes, and those of you that have been following us on Facebook, on Instagram, and on YouTube. And for those of you that have subscribed to our YouTube page, well done, thumbs up to you. Those of you that have not, please click the subscribe button on our page on YouTube, the Simplifier One. Now, I will start by answering a question that was sent to me based on our last video. Someone asked that why is it that when I drew the orbital diagram, the S was not split? The P I split in three, PX, PY, and PZ. Yeah, I'll start by explaining that. Now, if I place each of the orbitals, I told you there are four of them, the sharp, the diffused, the fundamental, and the principal. If I place them individually in a magnetic field, some will split, some will not split. Look at this. Let me just divide this. I have orbitals in a magnetic field. And over here, let me just put the shape. Now, my S orbital, that's the sharp. If you place it in a magnetic field, it does not split. Yeah, it will just remain with the same orientation. It will just remain there. Just keep swirling around without a splitting pattern. So, it will not split. And that's why the shape of this is spherical. Yeah, spherical. If I place my P in a magnetic field, it splits into three. It splits into three. Now, the three are PX, PY, and our PZ. So, you who asked that question, you see why our orbital diagram for P had three sections. One section for PX, another for PY, and the third for PZ. I hope you got that. And the shape of this is a dumbbell. You know what that is? Yeah, I believe you all know what a dumbbell is. Just something like this. I believe you've seen something like this. Yeah, if I have this as Y, and this is my Z and my X. Look at this, the dumbbell. I trust you understand. Now, how is it facing? The orientation is towards Y. That means this is my PY orbital. If the orientation is towards X, it is PX. If the orientation is towards Z, it's a PZ. This is a dumbbell shape. Okay. Now for my D orbital. If I place my D orbital in a magnetic field, it will split into 5. It splits into 5 orientation. And lest I forget, take note that PX, PY, and PZ, because they all emanated from a P orbital, they will have equal energy. The energy level of PX, PY, and PZ will be the same. And orbitals with equal energy level are called what? Degenerates. So anytime you come across this word, degenerate or degenerate orbitals, remember they are orbitals of equal energy. They must all have emanated from a source. So PX, PY, and PZ will have the same energy level. They came from P. Now, if my D splits into 5, these are the 5. I have my dx square. I have my dz square. I have my dxy. I have my dxz. And the dy squared to z squared. 5 different orientations. And remember, each of them will have the same energy level, so they are all degenerates. What is the shape of a d orbital? Double dumbbell. Double dumbbell. That is the shape of my d orbital. Now the last orbital, the F, that's the fundamental. This one has a complex. It will split into how many? Majorly 7. And the 7 of them are said to be complex. The shape of these is also complex. So these are the splitting patterns. So if I'm going to draw an orbital diagram that will involve D, the D part will have 5 sections. The F part will have 7 sections. The P part will have 3 sections, while the S will remain 1. Also take note that the maximum number of electrons that S can hold is what? 2. Anytime you see S holding a 3 electron orbital, tear that place. Wherever that source is wrong. The maximum that S can hold is 2 electrons. P, the maximum that P orbital can hold is 6 electrons. Are you getting the sequence? Yes, it is increasing by 4. The maximum that D can hold is 10 electrons, while the maximum that F can hold is 14 electrons. So I believe you understand this. So these are the magnetic field splitting patterns, the shapes of these orbitals, and of course, the maximum number of electrons that can be accommodated by each of these orbitals. So let's quickly go back to our carbon, and I told you that today we will look at the allotropic forms. So first, what is allotropy? Please don't confuse this. We have allotropy, we have allotropes, we have isotopy, we have isotopes, we have isomerism, we have isomers. Don't confuse this. Don't confuse this. I say again, do not confuse this. What is allotropy? This is the existence of an element in 2 or more forms in the same physical state. The existence of an element in 2 or more forms in the same physical state. Allotropes. Now look at the name, allotropes. These are elements, not existence now. These are elements that exist in 2 or more forms in the same physical state. I trust you understand that. So the existence of that word and without that word. So also isotopy and isotopes. Isotopy is a phenomenon. You have 2 or more elements. Elements existing in 2 or more forms, having the same what? Look at this, chlorine, chlorine. Chlorine 3717, chlorine 3517. You see that they have something in common. The atomic number. The atomic number is the same, but their mass numbers are different. So when you have an element, the existence of an element in 2 or more forms having different mass numbers, but the same atomic number. Now, if they have different mass numbers and the same atomic number, what else should be different? Yeah, of course. The number of neutrons. The number of neutrons will also be different when it comes to isotopy. So that's that. So if I'm going to define isotopes, I won't say it's a phenomenon. Oh no. This is an element that can exist in 2 or more forms, having the same atomic number but different mass numbers. I hope you got that. The same thing exists with this word, isomerism. Though this is for organic compound. So isomerism is what? You have a compound, 2 or more compounds rather, having the same molecular formula but different molecular structures. Yeah, that is isomerism. Look at this. CH3OCH3 and C2H5OH. Look at the formula. Look at the formula. What do I have in the formula? How many carbon atoms? 2. And here I also have 2 carbon atoms. How many hydrogens? 6. I also have 6 hydrogen atoms. How many oxygen? 1. And I still have 1 here. So their molecular formulas are the same, but the difference is in their structure. This is methoxymethane, while this is ethanol. You got that? Same molecular formula, different molecular structures, or different structural formulas. Now we'll come to all this, so I trust you understand the difference here. So here we're looking at allotropes. And I told you we have 2 major categories. we have the crystalline, and we have the amorphous, which we can also refer to as the non-crystalline. And I told you amorphous means shapeless. So we have the crystalline. The crystalline allotropes, this is diamond, this is graphite. And a third one that was discovered in 1985. In 1985, they discovered this, the fullerenes. The fullerenes. You know the fullerenes, we also call it the buckyballs. The buckyballs. And a major example of this is the buckminsterfullerene. The buckminsterfullerene, where you have your carbon atom, carbon 60, your buckminsterfullerene. So once you have carbon atom 60 and above, they are under the fullerenes. They are crystalline. You see them in a ball-like shape, and that is why sometimes they call them buckyballs. You see them in a ball-like shape, but the function, the use of these fullerenes is still being studied. Scientists are still engaging in studies to show the functionality of the fullerenes, but it is still crystalline. Now the amorphous, the shapeless ones, are the coal, the charcoal. We have the charcoal, we have lamp black, we have soot, and so on. There are so many of them. Now this, the classification of allotropy. In our next video, what we're going to do is we'll start picking them, looking at their general properties. Some of them look at, like the diamond is octahedral in shape. Graphite is not octahedral, it's hexagonal in shape. So we'll consider each of the properties of these allotropic forms of carbon. I'll see you in the next video. But remember, go to our Facebook and our Instagram page, The Simplifier 1. Go and like our videos, comment on our videos, ask your questions, and please share the videos. Then don't forget, go to our YouTube platform, remain in our YouTube platform, click on the subscribe button, and these videos will keep rolling in. Thank you very much for watching. See you in the next video.